Today, we will be going over one-step equations. And when it comes to equations, one thing we always want to remember is to undo the operation performed to the variable. So what does that mean? Well, that means if they subtract 5 from the variable, we need to do the opposite. We need to add 5 to that variable. If they add 4 to a variable, then we need to subtract 4 from the variable. So we want to undo the operation, which is addition, subtraction, multiplication, and division. We want to undo that operation performed to the variable. Okay? So, for example, 1, we have x minus 5 equals negative 22. All right? X minus 5 equals negative 22. So, here's the variable x. They subtracted 5, so we want to add 5 on both sides. On both sides. So let's add that to step 1. We want to say on both sides of the equal sign. So we want to add 5 where? Both sides of the equal sign. So this cancels out. So we're left with x equals negative 17. X equals negative 17. So here we have 4 equals 7 plus p. So what operation is being performed to p? Well, they're adding 7 to p. So if they are adding 7, then of course we need to do the opposite, which is subtract 7 on both sides of the equal sign. Positive 7 and negative 7 cancels out, so I'm left with p, which equals 4 minus 7, negative 3. P equals negative 3, or negative 3 equals p. It is really the same thing. So now you can go ahead and pause and do number 3. Yes, it is a fraction. However, you still do the same thing. All right, so we have p plus 1 over 10 equals negative 3 over 4. So I want to do the same thing. What is happening to the variable? They're adding 1/10, so I want to subtract 1/10 on both sides. Here it cancels out, so I'm left with p equals, and then I need negative 3 over 4 minus 1 over 10. Now, you can either find a common denominator and subtract it that way, or you can turn these into decimals. So that's negative 0.75 minus 0.10. I mean, 0.10 or 0.1, which will give you negative 0.85. Negative 0.85. Now, number 4. Try number 4. You can pause it at this time. All right, we have t plus negative 16 equals negative 24. So, what are they doing to the 16? To the t, the variable. They're adding negative 16. However, in this sense, we are getting 0 pairs. So if it is a positive 1/10, we want to subtract 1/10. Alright, so here we have negative 16, so we just want to make a positive 16 so we can cancel this part out. And we do it on the left side, we of course need to do it on the right side. Okay, and a better way to see that, well, if we were to KCL and change this, it would be t minus 16 equals negative 24. So that is still saying t plus negative 16. So you can clearly see this way that they are subtracting 16 from t. So we add 16 on both sides. We get a zero pair here. We're left with t equals negative 24 plus 16, which is negative 8. And the way to check your answer is to just plug in t, your answer for t. So we have negative 8 plus negative 16. That does equal negative 24. So we know that our answer here is correct. Now we have more examples, examples 5, 6, and 7. All right. So same concept, except with the first one we were looking at addition and subtraction. Now we're going to look at the second part of it, which is multiplying and dividing. All right. So the same concept applies. You undo the operation performed to the variable on both sides of the equal sign. So if I have 36 equals negative 12y. What is being done to the variable? Here's y. It is being multiplied by negative 12. So how do you undo or reverse the operation? If it is being multiplied by negative 12, you want to divide by negative 12 on both sides of the equal sign. This cancels out. You're left with y. And then you have 36 divided by 12, which is negative 3. If I wanted to check it, I can rewrite this and sub in my answer for y. So 36 equals negative 12 times negative 3. 36 equals negative 12 times negative 3, which is 36. So I can check that my answer is correct. So try number 6. You can pause it at this time. All right, so for number 6, we have 4 equals x divided by 14. So if they divided by 14, I need to multiply by 14 on both sides of the equal sign. So now I have 14 times 4 equals x divided by 14 times 14. If I could just get to my calculator. So these cancels out. I'm left with x, and 14 times 4 is 56. If I want to check myself, I just rewrite it. And then I sub in my answer for x. So 4 equals 56 divided by 14. So I want to check to make sure that 56 divided by 14 is 4. I get the same thing on both sides. I know my answer is correct. This is a very important step. It's checking your answer to make sure that it is correct. Alright, lastly is number 7. So we have 5y equals 3 over 2. 5y equals 3 over 2. So what is happening to y? It is being multiplied by 5, so I need to do the opposite and divide by 5 on both sides. This cancels out, so y equals, I need to do this to the side. So we have 3 over 2 divided by 5, and we know we have to put that whole number over 1. So we KCL, keep, change the division sign to a multiplication symbol and flip or do the reciprocal, and we get 3 over 10 as our answer. So y equals 3 over 10. If I wanted to check, I can write 5, y equals 3 over 2. Sub in y, my answer for y, so that's 5 times 3 over 10. That should give me 3 over 2. So if I multiply these two, I get 5 times 3, which is 15 over 10, which simplifies to 3 over 2, which still gives me my answer of 3 over 2. So I know it is correct. So y equals 3 over 10.